Hi, my name is Tyler Larsen, and this is my video presentation for Project 3 in Design and Manufacturing, taught by Dr. Hassan Rashidi. In this project, we selected 5 manufacturing topics to research and present, so I will now begin with my first topic. The topic I selected is gravity casting. Gravity casting is a fundamental manufacturing process that uses the force of gravity to fill up a mold with molten metal. I've had some experience of my own in my backyard playing with casting techniques, as you can see in the bottom middle. There are many variations of gravity casting, so I've highlighted a few of the most important capabilities and limitations. You can use a wide range of metals, make complex parts, and produce less scrap than other manufacturing techniques, and make parts with high surface finish quality and excellent dimensional accuracy. The limitations can be the die and labor costs, especially if you're making a permanent die. And the part size is also limited in many cases. To name a few applications, the gas industry uses cast parts for valves, compressors, and so on. The aerospace industry uses casting to make critical components that require the utmost precision and strength, and the automotive industry also uses gravity casting for things like engine pistons, brake calipers, and housings. Gravity casting is important because it is one of the earliest known methods of making metal objects. And as it's been more advanced over time, it revolutionized manufacturing, allowing manufacturers to produce parts in higher volumes than what was previously possible. And finally, gravity casting can be a great method to reduce parts in a design, rather than welding together a bunch of smaller parts, as you can see in this image. The next topic I selected is rod, wire, and tube drawing, also known as just drawing for short. Drawing is an operation in which the cross-sectional area of a bar or tube is reduced and changed in shape by pulling it through a converging die. In some cases, multiple dies are used to draw out the material progressively. And also, the drawing process you can think of as very similar to extrusion, except that the workpiece is under tension instead of compression. To name a few of the capabilities, the drawing process produces high-quality surface finish and high dimensional accuracy. Also, it's very fast with high speed and torque control. The available material selection can be limiting though, and some amount of waste will be generated if something goes wrong due to the high speed of production. Also, drawing might not be the best manufacturing option at small scale, since drawing is most cost-effective at very large scales. So drawing has extensive applications. Rods produced in the drawing process are commonly used for shafts, spindles, and structural members, and also in the raw material used for making fasteners such as bolts or screws. And the application for these spans so many industries that we could just say that we rely on them for almost all the machines and structures that we build and use every day. And similarly, wires have a wide range of applications too, such as in electrical wiring, cables, mechanical springs, musical instruments, paper clips, fencing, welding electrodes, even shopping carts, and so many other things. Since wires can be turned into many more complicated products, the applications for them are endless as well. To sum it up, the importance of drawing. Modern society is built on products made using drawing manufacturing techniques. Thousands of finished products rely on drawn rods, wires, and tubes. And finally, millions of miles of wire are drawn by metalworking companies annually, making it a really significant manufacturing process in the modern day. The third topic I've selected is cutting fluids. So cutting fluids are a mixture of often water, oil, and other additives that are commonly applied to the cutting edge of a tool during a manufacturing process. And they have a significant positive impact on the tool they're applied to, improving the tool life, productivity, and ultimately the product quality. Cutting fluids perform 3 major functions, which are lubrication, cooling, and removing chips from the cutting zone. So here are the capabilities of the cutting fluids. First, cutting fluids act as a lubricant. They reduce the amount of friction between the tool and the workpiece, which reduces the amount of necessary cutting force. And the result is that production speeds can be increased and energy consumed is reduced. Second, cutting fluids act as a coolant. The constant application of fluid removes heat from the tool and workpiece, which helps reduce the amount of tool wear and can prevent warping, which improves dimensional accuracy. And third, cutting fluids act as a chip transporter by clearing away chips produced in the process. And this helps prevent clogging or damage caused by the chips. However, cutting fluids have limitations too. Sometimes they can actually be harmful to the tool. For example, when milling, the cooling action can cause thermal cycling in the cutter teeth, which can lead to the development of cracks. And it's also important to keep cutting fluids well contained so that they don't spill out into the workshop. Lastly, it must be properly disposed of and can be hazardous to the environment and even to humans if it's not handled properly. Most machining processes benefit from cutting fluid though, so I wanted to list some of the most important applications. So cutting fluids can help make the turning, milling, drilling, boring, tapping, grinding, and CNC machining processes much more efficient, among many other processes. The top image shows cutting fluid being applied at a slow rate to the workpiece, and in contrast, in the bottom image, you can see a high-pressure jet of cutting fluid. And there are many ways to apply cutting fluid, sometimes even missed. It just depends on the machining process. In a nutshell, cutting fluids have become essential in manufacturing. Using them effectively can lead to increased efficiency and productivity, increased tool life expectancy, and overall, cutting fluids help get the job done a lot better. The fourth topic I selected is lathe and lathe operations. A lathe is a machine used to shape cylindrical products, usually made from wood, metal, or similar materials. It works by rotating the workpiece about an axis, while a stationary cutting tool progressively removes unwanted material until the workpiece is formed into the desired shape. There's so many capabilities that a lathe machine has. To list a few, it can turn round stock, make round profiles, cut grooves and threads, drill into the tail end of a workpiece. It's really an awesome machine that can be leveraged to make a lot of interesting features. However, some of its limitations are related to work holding, which can be tricky for some parts if they're in awkward shape. And also, most lathes have a maximum length and maximum diameter that they can handle. Finally, out of round turning can be dangerous since a spinning piece that is off-balanced may cause injury or other damages. The applications of lathing are very extensive, and I've pulled up some beautiful woodworking images to demonstrate them. Stock can be turned into round parts of practically any shape, meaning we can make bowls, mallets, like you see, handles, boxes, pens, chopsticks, dowels, and so many more things. And also, you can do more clever techniques to produce more decorative features like on the table legs on the right. So why are lathes important? Well, lathes are considered to be one of the oldest machining tools. And although woodworking lathes were first developed 2,000 or 3,000 years ago, metalworking lathes were not built until the late 1700s. And then during the Industrial Revolution, lathes were key machines to producing dimensionally accurate round parts for engines and other machines. And also, the use of modern computers makes lathing operations even more efficient and complicated, since parts can be produced more rapidly and accurately than ever. The fifth and final topic I've selected is the hexapod machine in manufacturing. So a hexapod robot is a 6-axis parallel kinematics machine often used for automated precision positioning and alignment of parts and components ranging from miniature optics to large panels. Hexapod machines have a smaller size, higher stiffness, better dynamics, higher precision, and a greater flexibility than traditional robots. The user programmable pivot point allows rotations around a center in space and multiple coordinate systems. Additional advantages are the lack of dragging cables, which are more common with classical serial multi-axis positioning systems. However, they're limited by vertical reach, which makes them less effective with tall objects or when a wide range of vertical motion is required. And also, they're pretty slow in terms of movement speed, which is a good thing during careful operations, but it can be limiting to overall production speed. The newly developed hexapod precision motion system is specifically designed to meet the boundary and environmental conditions of the application, making it particularly optimized for time-critical manufacturing processes with tight tolerances required by the aerospace industry, for example. Also, automotive suppliers have discovered hexapod's particular usefulness for coordinate measuring machines to calibrate headlamps and to align optical components that are becoming more and more mainstream for autonomous driving, for example. Also, precision laser welding and micromanufacturing can also be improved with the help of hexapods. As the precision requirements in the automotive industry especially are increasing, the need for advanced robotics arises. Traditional robots are fast and can handle heavy loads, but they lack the positional accuracy that hexapods exceed at. So hexapod robots already have a history in precision alignment and micro-manufacturing automation, but at first they were considered too precise for the automotive industry. However, now the situation is changing, and the need for precision has greatly increased. Finally, here are all of the resources I used for these 5 topics. Thank you for listening. Hope you enjoyed.